Okay, so get this. What if I told you that a visitor just passed through our solar system, a visitor that's almost as old as the universe itself? Yeah, a traveler, carrying secrets from the very dawn of our own galaxy. We've got to dive into this incredible story. So here it is. This is Comet 3I/Atlas. And look, this isn't just any comet. It's an interstellar object. That means it's a visitor from a totally different star system. You got to think of it like a cosmic time capsule, just hurled through space for billions of years before finally crossing our path. I mean, what a journey it must have had. But the thing that is just absolutely staggering is its age. We're talking about an object that is potentially 12 billion years old. Now, to put that into perspective for you, our own solar system, it's only about 4.6 billion years old. So this comet was already ancient when the Earth was just a cloud of dust. It literally formed right after the birth of our Milky Way galaxy. So you see, this isn't just a visitor from another place. It's a visitor from another time, which poses a huge question for scientists, right? How do you even begin to piece together the story of something so ancient and so incredibly far from home? Okay, so you might be wondering, how did astronomers know this wasn't just, another rock floating through our cosmic neighborhood? Well, it all started with a few key clues that immediately tipped them off that this thing was something incredibly special. So the comet was first spotted back in 2025, and almost right away, its path got flagged as interstellar. See, it wasn't orbiting our sun in a nice, predictable loop like the comets we're all used to. No, this thing was on a path, a trajectory that could only mean one thing. It came from the deep, vast space between the stars. And here's the other major clue. Its speed. 3I Atlas was clocked moving at an incredible 58 kilometers per second relative to our sun. That is it's the fastest we've ever measured for an object like this. It's moving so fast that our sun's gravity can't hold on to it. It was never here to stay. It was just passing through. But, its speed was really just the beginning of the story. To truly understand where this thing came from, scientists had to look way deeper. They had to analyze its chemical makeup, basically crack its cosmic code. It was time to do some cosmic forensic analysis. And lucky for us, we have the perfect tool for that kind of job, the James Webb Space Telescope. By pointing its incredibly powerful infrared spectrometer right at the comet, astronomers could analyze the light shining off it. And that light tells you exactly what it's made of, creating a unique chemical fingerprint. Okay, so they have this chemical fingerprint. Now what? Well, this is the really clever part. They use that fingerprint to tell time. The key was a technique called isotopic analysis, and you can think of it as our very own cosmic clock. Let's break that down real quick. An isotope is just a different version of the same element. See, an element is defined by how many protons it has, but the number of neutrons can change. And that tiny, subtle difference in weight, well, that's the secret to unlocking this comet's incredibly ancient past. So let's take carbon as an example to see how this works. You've got carbon-12 and carbon-13. They both have 6 protons, which is what makes them carbon, but carbon-13 has 1 extra neutron. That makes it just a little bit heavier and way, way rarer. And believe me, that tiny difference means everything in this story. So why does any of this matter? Well, it's because the amount of carbon-13 in our galaxy has actually changed over time. Right after the Big Bang, there was hardly any of it. It's mostly created and then shot out into space by dying stars and huge explosions called novae. So as billions of years go by, the galaxy gets more and more enriched with this heavier carbon. The takeaway? If you find something with a really low amount of carbon-13, you're looking at something very, very old. And that wasn't the only clue. They also looked at the comet's water. Turns out it had really high levels of something called deuterium, which is just a heavy isotope of hydrogen. And a signature like that, it points to the object forming in an extremely cold, primitive environment. Exactly the kind of conditions you'd expect to find in the very, very early universe. All right, so the stage is set. We have the tools, we have the clues. It was finally time to reveal the verdict on Comet 3I/Atlas. So what did its chemical fingerprint actually tell us? Well, the very first thing that jumped out was just how alien it was. One of the lead researchers even said its chemical signature was totally different from anything we normally see in our cosmic neighborhood. It was a crystal clear sign that this thing came from a very different time and a very different place. And then came the big one, the aha moment. When the scientists measured the carbon, the result was just wow.
They found an exceptionally high ratio of the common carbon-12 compared to that rare, heavy carbon-13. This was the smoking gun. This was the irrefutable proof that this comet had to have formed in an ancient, unenriched environment way back before our galaxy was seeded with all these heavier elements.
This timeline really puts it all into perspective. So the universe begins 13.8 billion years ago. Then just a billion or so years later, while the very first stars are still blinking on in our galaxy, this comet is born. Our solar system, it wouldn't even exist for another 7 billion years. It's just an unbelievably ancient relic. And here's a pretty profound thought for you. The star system where this comet was actually born, it's almost certainly long gone. That star has probably lived out its entire life and died by now. That means this comet, it's a true orphan. It might be the last remaining piece of a solar system that completely vanished billions of years ago.
So, beyond the sheer coolness of finding a 12-billion-year-old object flying through space, why is this discovery so important? What does it actually teach us about our own place in the cosmos?
Because this comet is so much more than just a ball of rock and ice, it's a messenger from the past. It's carrying a pristine, untouched sample of the raw materials, the very cosmic dust and gas that the very first planetary systems in our galaxy were built from. So really, this message in a bottle gives us a few incredible things. First, it's a direct window into the chemistry of the young Milky Way. We get to see what things were like back then. Second, its composition, full of carbon and water, is proof that the building blocks for life were around very, very early in our galaxy's history. And finally, it's a real, tangible link to the very first planets that ever formed. Which, of course, leaves us with a pretty tantalizing final thought. If a 12-billion-year-old messenger just happened to fly through our backyard, what other incredible messages from our cosmic past are still out there, just waiting for us to find them?